What is going on, guys? What is going on? In today's video, we're going to be going over Schematron 3B and 8B. These two tiny open source models are not trying to be chatbots, coding assistants, or vision language models. They do one thing and one thing pretty well. They take messy HTML and turn it into clean JSON. And what makes them interesting, it's not that they are like specialized, it's the fact that Inference.net, which is the company that's behind the models, claim that they can reach near frontier extraction quality at roughly 1 to 2% of the cost and is 10 times faster at inference than large general purpose language models, as you guys can see here. Their benchmark actually shows Schematron 8B scoring 4.64 on HTML-to-JSON extraction, pretty much close to ChatGPT 4.1 that scored here 4.74, while Schematron 3B scored 4.41. So instead of prompting it with something vague like, hey, summarize this product page for me, the instead workflow is more like, here's the HTML, here's my schema, extract product name, age, location, and you basically get something like this. Now, my personal specs are the NVIDIA RTX 5060 Ti, 16 gigabytes of VRAM, backed by 64 gigabytes of system RAM. But however, you can run these models on way less than that, especially thanks to the open source community giving us quantized variants that we can choose from. And that means that you can pretty much run the 3 billion model on around 4 gigabytes of VRAM, and the 8 billion model on around 6 gigabytes of VRAM, right? You don't want to go too low on the quantization. Stick to around Q4 or something like that. And these models are not just all talk, and these are the benchmarks. Even one of the key figures from Inference.net posted this on X a couple of weeks ago. So this really means that it's not just talk the talk, it's actually walk the walk. These models are actually being implemented in production pipelines. And another cool thing is that when you pair these models with web search, they're actually able to boost GPT-5 Nano's accuracy from around just 8.5%, as you guys can see here, all the way up to 82.8% on a simple QA benchmark. Now, before we jump into testing the models, as always, let's just quickly jump into the architecture and see what's actually going on underneath the hood of the models. These aren't just generic chatbots. The Schematron series are built on the Llama 3.1 and the Llama 3.2 base architectures. And because of this, both the 3B and the 8B inherit the 128K context window, making them a great fit for scraping bloated large web pages. And also, this is a critical thing to keep in mind, is that Schematron is listed as taking in static HTML only. So if a website is heavily client-side rendered, pretty much need to render that content upstream first with something like Playwright, which we're going to be using in this video, or Selenium, or another type of tool for the automation layer. So Schematron in itself is not necessarily replacing your JS rendering stage, but rather it's replacing the brittle handwritten extraction stage that usually comes after rendering and cleaning. Now, to test the models, we're going to be using Llama-cpp-python inside of VS Code, but I'm also going to be showing you guys how to test the models in Inference.net's official playground, as you guys can see here. I mean, it's pretty straightforward. You can just click on custom, paste in the link that you want, hit JSON schema, and then hit run. So we're going to be going over that as well, but just to show you an example though, we're not going to be doing all of the tests here. We're going to be doing them locally. And for the local runs, we're going to be testing the model's ability to extract data from 3 input types. So the first one is going to be a local HTML file, which is this one. It's like saved on my computer, and you guys can see the code. We're going to be extracting things like the price, the amount of bedrooms and description and the address and all that stuff. But as you guys can see, there's a bunch of like unnecessary information here. So we're going to see the model's capabilities of ignoring all of this and all of this and this and all of this stuff, and only giving us specifically what we are asking for. And then we're going to be testing out a static web page, which is this one. And I specifically want to target the philosophy category of books to scrape. This is a site that's literally meant for scraping so that you can test out scraping tools and stuff like that. So yeah, we're going to be going for the price, the title of the book, the rating, and also a URL to the thumbnail. And the last one is a JS rendered web page. So this web page actually relies on JavaScript to load up the content. So like just fetching the page here won't work. So we're going to be testing out the model's capabilities of pulling that off using using Playwright. Yeah, so those are the 3 tests. And in order to download the models, you can just head over to Schematron's InferenceNet Hugging Face page, click on File and Versions, and you'll be able to get the models from here. However, I'm going to be going for the Quantized variants of them from Mr. Marcher, and I'm going to be going for the Q8. And the reason for that is, if you guys look at the 16 version one, it's literally like 16.1 gigabytes. And since I'm running on a 16 gigabyte card, it won't fit, right? But if you look at the Q8, it's 8.54. So that will leave me with enough headroom to fit the entire model, the 8 billion one. Of course, the 3 billion won't be a problem, into my card. I mean, and pretty much the quality difference between these two it's pretty much the same. And I mean, he even says it here, right? 16 bits per weight is overkill. So yeah, so we're going to be sticking to the Q8 for both the 8 billion one and also the 3 billion one. I mean, this is hardly anything at all, right? So yeah. Yeah, so just a quick overview of the code base. I created a quick README here, as you guys can see. The schemas.py, it basically just defines the schemas that we want, right? So I can just show you guys here. For example, the scrapes to book, we want the title of the book, we want the image URL, we want a rating, and we want to know whether or not the book is in stock. It's pretty self-explanatory. And the JavaScript rendered page, we want the title, and you can also see the description here. The image, again, URL to the image itself, and the price of the specific item. And this is just the overall page as a whole. From the overall page, we just want the page title and the products, which is then each of these individual cards. So yeah, that's pretty much it. And then the third one is the real estate test site. This is just some random stuff that I was testing. But yeah, this is the real estate test site. As you guys can see here, we are asking for the address. We want the price. We want the number of beds, bath, square per feet. And then we have a summary and then the listing URL. So this is what we're asking for, right? This is the schema that we're outlining to the model to go and fetch for us. And let's go back to the README. And then we have the config JSON. This is where we can select whether we want to be using the 3 billion one or the 8 billion one. Let me show you guys the one for the books, for example. So if I wanted to use the 3 billion, I would just change it here. And if I wanted to increase the context window, I will just change it here. Also the seed, but this didn't really do that much of a difference. And this is if you want to do like smoke test, you can just add a quick one here just to see if the model works at all. This is the URL of the page. The rest of this stuff is more geared towards saving the file. For example, here, that will end up here. And if I wanted to use Playwright, I could turn it on and off here. So since the book one is a static website, I actually turned it off. But if you look at the clothing website, you can see that it's on, right? Since it's JavaScript rendered page, so we will have to use Playwright in order to parse it. And then go back to README. Yeah, and then we have the script itself. I mean, I'm not gonna bore you guys with it. I mean, it's pretty beefy. But basically what the script does is that it takes the configs that we have in here, right? And we can either feed it 3 types. The file, this is the file that I showed you guys that looks like this. So we can either feed it a file, or let me just go back to config. We can feed it a text. Again, this is just to do smoke test, or we can feed it a URL. And then if we feed a URL, we can decide whether or not we want to use Playwright here. So that's pretty much what the script itself does. So let's go back to the README. Yeah, and this is a couple of the things that are going on in the script itself, like the pipeline. So it removes noise. So when it gets a page like this, obviously this one is very simple and basic. So what the script does is that it will basically clean all of this up. It will remove like scripts, styles, and comments, and extra white space and all that stuff. And then step 6, we are, basically telling the model to give us the title, image, URL, rating, and stuff like that. And step 7 basically sends the clean HTML that we did here, plus the schema that we provided it here, right? The schema from here to the GGUF model. And then it runs the selected Schematron model that we selected here. Yeah, read the model's response, validate it, and then it gets printed here at the very end. So yeah, let's do a test. So the first one obviously is going to be the example input, this one right here. So let's do a quick one. So yeah, we first activate the conda environment and then we paste it in. And for this one, we're going to be starting off with the 3 billion model first. And here you can see my current average VRAM and peak, and then we hit run. Obviously, the first time it always takes a little bit longer, but after that, it's way faster. And again, for this test, we are basically asking Schematron to give us this one, right? These values. So here it is. And as you guys can see, it worked. So it gave us the address, the price, how many beds, bathrooms, how big it is, the address, and this is the page. Yeah. It was able to pretty much filter out all of this other noise and give us the address in Austin, Texas. And then we have Tampa, Florida. You can see Tampa, Florida is here. And then the third one, which is Cedar Park, which is the third one. Yeah, so it worked. And the peak was 5.9 gigabytes of VRAM. Now let's quickly test with the 8 billion one. So in order to change that, I go in here and then I press 8 billion, hit save, and then run it again. This is probably going to spike, obviously. Yeah, now it's at 9.5. Around now it's 10. And there it's finished. Yeah, so this one took around 25 seconds and the other one took around 10 seconds. So the 8 billion obviously is a bit slower, but that's to be expected. So let's look at the 8 billion one. Yeah, it's pretty much the same, right? So for this type of extraction, it doesn't really matter which of the models you use. They will pretty much do exact same thing. So yeah. So let's move on to extracting the static web page. So for the second test, we're going to be checking out the model's capabilities of extracting like these specific fields, like the title, image URL, rating, and whether or not the book is in stock. Again, it's this specific website. So these are the fields that we are going after. I'm going to be using this specific config file, which loads up the 3B model. Yeah, the context size is 8K. Let's just hit run. Now this is where it gets interesting because as you guys can see from this specific output, there was nothing. So you might be thinking, oh, maybe it's broken, maybe something is wrong. Well, let's now change it to the 8 billion one instead. So we just go here, hit 8B and hit run again. Now it immediately shot up to 11 gigabytes. Again, this is around 25 seconds or so. Another one is usually around 10 to 15 seconds. Yeah, so just waiting for it to wrap up. Now this is with the 8B. And as you guys can see, the 8B was able to pull it off, but the 3B wasn't. So there's obviously a difference quality-wise. This is also where it gets a bit interesting because some of the fields are obviously wrong. And also here it says books -to-scrape-sandbox, and that's wrong because on the web page it looks like this. Paste the URL in here. This is how the URL looks like, but it gives out this. So yeah, the model hallucinated. Then I thought, okay, let me test out the same test on their specific website, and on their website it wasn't better, to be honest with you, because as you guys can see here, it has a wrong URL. Right? It's still not the correct one. And here on the rating, all of the books are 5, 5, 5, 5, 5, 5, 5, 5, 5, right? But then my pipeline was actually able to catch it. 5, 4, 4, 1, 1. Yeah, so it's not perfect. That's like my whole point here. So just keep that in mind. It's not gonna crush it every single time. However, it does make things easier, obviously. So yeah, so let's move on to the last test where we're gonna be testing out the JS rendering part on this specific website. And again, this site is also meant for scraping. So we want the fields of the URL of the image, and then we want the title and then the price of the item. Right, so yeah, let's go back to VS Code. So we're going to start off with the 3 billion model. Go in here. Yeah, it's already at 3 billion. And again, we are going after these fields right here. Image URL, price, and description of the clothing. So we're going to hit enter. And now you can see the website popping up. And the reason for that is because now we're using Playwright. And I turned off headless mode. You can see the average VRAM here. And I show you guys here. Yeah, so you can see headless here is false. If this was in production, you would leave this to true, obviously. So yeah, now it's done. Let's look at the results. So this was what it was able to get. Again, this is the 3 billion one. Able to get the title, the image URL, and the price. So this one is Chaz Kangaroo hoodie, 52 bucks. Let's check the site. Yeah, 52 bucks is correct. The third one is Bruno Compete hoodie, 63. Bruno Compete hoodie, 63. Let's check the second last one. Grayson Crew Neck Sweatshirt, 64. Yeah, it's correct. So let's test out with the final, the 8 billion one. Go in here, change this to 8 billion, hit run, go. And then let's keep a track on the average. VRAM consumption, it's obviously going to go up again. It actually wasn't that high. Even the 8B, it was around 2.5. So yeah, let's check the results. So this is the 3 billion one, and this is the 8 billion one. I mean, it's the same. And yeah, I did cross-check it. It's pretty much the same. So for the JavaScript rendered page using Playwright, both of the models were pretty much neck and neck. However, for the second test, for this one, the 8 billion was better. It did hallucinate. It did struggle a bit, but it was still better because the 3 billion wasn't even able to give us anything. I do have to say, though, on their website, their 3 billion one was actually able to give you a response, but it was a bunch of errors, and yeah, it was just hallucinating a lot. So I'd rather go with not getting anything at all than to get something, because you will have to do a lot of cleaning anyways. So yeah. So that's pretty much it. Just a quick tip. So when it comes to a web extraction pipeline, Schematron's job is not really to get the URL of the website, right? To fetch it. And it's also not to use Playwright that I showed you guys, right, on a render.js page. And it's also not to clean it up. Its only job is to really take the JSON schema that you give it and the clean up HTML. And then you can validate it, obviously, if you're using Pydantic or Zod. And then it will give you the JSON. That's its only job. So if you're doing this on a production scale, you would still have to do all of this. But fortunately, in today's age, most web scraping websites, they will pretty much do all of this for you for a very small fee. And as I showed you guys in the tweet before, they're even starting to leverage AI now using Schematron. So they will actually handle all of this for you. And all you would have to pretty much do is to just validate it and then use the JSON itself. But if you are doing this on a very, very small scale, like a couple of requests per day, maybe in the hundreds, you should be able to do all of this locally. But again, if you're doing on a production scale, you would have to use professional tools. So just keep that in mind. And this is the typical pipeline and how it looks like without Schematron. You would have to do a lot of manual work, right? You would have to do all of this. And if the website just changed just a little bit, your pipeline will like immediately break. So that's like what Schematron aims to solve, right? To take this messy part out and allow you to just use natural language instead. And as you guys can see, I would say the 8 billion does have a slight edge over the 3 billion, but the 3 billion is on par on certain specific tasks. But if you want the highest quality, obviously go with the 8 billion, okay? So yeah, with that being said, if you guys were able to get some value out of this, be sure to hit the like button. Don't forget to comment and subscribe, okay? It's not that hard, guys. Just hit the subscribe button, and I'll see you guys next time. Take care. Peace.